With the title OPC UA for Process Air Extraction and Filtration Systems, I would like to welcome Mr. Benjamin Wirth. He's the chair of the working group OPC UA Air Pollution Control and works for the ULT AG. And now I'd like to hand over to you, Benjamin.
Thanks a lot for introducing me and for having me on your event series here. And as was already mentioned, I'm going to present OPC UA for process air and extraction filtration systems. We've published our companion spec about a year ago, and well, it's about time that we are presenting it to a lot of newcomers to this topic. I'm going to start to introduce you to into the domain to show you what is a process air extraction and filtration system. I'm then going to show you the use cases that we are mentioning in our companion spec, show you details about our information model, and the next steps that we are going to take with our companion spec. First of all, what is an PAEFS, a process air and extraction and filtration system? Process air is atmospheric air that is in contact with a manufacturing or a production process that needs to be cleaned either for the process to function, to work, to produce what it's producing, or to remove contaminants that are created while the process is taking place, while the manufacturing is taking place. And the extraction and filtration systems are those components that are moving the air and are actually removing the contaminants from this air. The next slide, I've got an example that we're also using in a publication of the VDMA about welding fumes. And here you do see on the bottom right side the manufacturing process. In this case, it's a welding process. And in the middle, you've got the filter unit, the filtration device, and everything that is around it. For example, the exhaust air duct and the air intake here, the filtration elements or the separators inside, the blower, the dustbin of the system. All those components are part of an process air extraction and filtration system. In the next 3 slides, I'm going to show you the multitude or the variety of those systems. First, it's a simple system that has got a lot of subcomponents. So you've got an air intake, you've got a spark separator, air intake valves, the filter cartridges, filter cleaning unit, secondary filter cartridges, and a filter aid device. So this is a simple system that has a lot of subcomponents installed in it. And the next one is an extraction and filtration system that is created in a redundant way, meaning you've got 2 air intake connections, you've got 2 cartridge filter systems here, you've got 2 blowers inside or that are incorporated in the system, and you've got a single exhaust air connection. So this system is set up in a very different way compared to the system that we had beforehand. Also, the amount of subsystems of this system is different. And the third slide here is showing a different way this extraction and filtration system is working, meaning that you've got also an air intake connection, and then you've got an electrostatic precipitator that is working with a 3-stage system. However, you also have got a fan and an air outlet connection, even a secondary fan here in this case, and a temperature regulator. Those slides I've just shown are here to present you that there is a multitude of different applications, of different ways to extract and filter. And in our working group, we had to find a common way to describe extraction and filtration systems, and that was the main task of that we had before we could create our companion spec. The collaborators in our working group were mainly members of the VDMA Specialist Department Air Pollution Control. We had 11 active main members that are mainly from Germany and Austria. You do see them here on the right-hand side. I won't read all of those companies. However, every company took part in the creation of our companion spec, and we also had 11 passive members that were informed, that gave us feedback sometime about our progress in the creation of the companion spec. The whole operation was obviously supported by the VDMA, and we had support by FVA GmbH in Munich. They were the editor of our companion spec. The companion spec had this timeline here, meaning that we met the first time in July 2019 and created a joint working group with the OPC Foundation in January 2021 in the midst of the pandemic, and we managed to release our release candidate in October 2022, and the first final release in August 2023. So it took us about 4 years, and also the way our group was working together changed a lot. So in the beginning, we had a lot of meetings in Frankfurt, for example, where we met in person, and afterwards we shifted to online meetings, like I think the majority of other groups did. So now let's take a look at the use cases of our companion spec. The use cases are device identification, monitoring, maintenance, and operation. Those are very generic use cases, and I'll show you what we mean by this. The first one is mere identification, meaning that you've got an asset manager, for example, who wants to know what kind of machines and devices he's got in a system represented in this hierarchical graph here. The next use case would be a device monitoring, meaning you've got a centralized system that has to know the state of each machine, where the process air extraction and filtration system will provide the data about its state to the centralized monitoring system. And the third one is about device maintenance, meaning that you've got a plant operator or someone who's providing service, who has to check the device health, who has to look into the state, for example, of the separators of the device, and plan his maintenance operations accordingly. And the third one is our main use case, meaning that the PAEFS provides data and may be controlled by other machines. It might be one machine, or there might be several machines where the device that is connected to our process air extraction and filtration system does not only receive data, but we provide methods and other ways that those machines, or even if it's a human operator who's using OPC UA client, may interact with the PAEFS device. Yeah, so those were the use cases that we used in our companion spec. And the next slides, I will continue with the information model, meaning, or that'll show you how we incorporated those different ways extraction and filtration systems are working and the use cases into a common rule set or frame for all of those companies that collaborated for the companion spec. Our companion spec shows that we view filter systems or PAEFS in a multi-stage way. First of all, we've got a common object that is the filter system type, or a common type that's the filter system type that unites all of the subtypes or all of the objects that a filter system will later on be composed of. And each filter system has at least one air intake. That was a thing that I showed with the examples before. So there will always be an air intake, and there will always be an air outlet of our system. And each filter system will be will incorporate at least one filter unit. Then there may be subsystems that are not always present, and the amount of those subsystems may vary from one device to another, meaning that we may use temperature regulators. There may be fans or blowers that are incorporated in our filter system. There may be or not be filter safety systems and filter aid devices. The main component of each filter system will be a filter unit. And each one of those filter units, on the other hand, may also have an air intake and an air outlet, and use a separator. I will talk about the separator in a minute. So the separator is the main element that does the filtering in our filtration devices. There may be a dust discharge system if we are talking about cartridge filters, for example, that have a dedusting or a cleaning system. And the cleaning system is the system I just talked about that removes the dust, the accumulated contaminants from the separator, and each cleaning unit may also have valves that are used, for example, for pressurized air to clean the dust of this separator. In this graph, we have got a second way to describe the relations with these objects or types. And this is a users relation. This users relation is used in this companion spec to describe a relation between filter units and fans or temperature regulators, or between separators and discharge or cleaning systems. I showed the example of this redundant filter device that consisted, or a filter system that consisted of 2 filter units. So each one of those filter unit had a proprietary or an own fan. They had a separator, and each one of those separators had an own discharge system and cleaning system that was connected to this separator. So this uses relation is used as a way for the human to detect which separators are connected to which discharge systems or cleaning units, and on the other hand, which filter unit is connected to which fan. Yeah, so this is the explanation about the topics are about the filter system type and the filter unit type that I just talked about. And now let's focus on the separator type. So this is the part that does the actual filtering, and we use 4 different subtypes. The cartridge filter is the generic subtypes, the subtype that does not use any specialized variables or data, whereas the wet separator, the automatic roll band filter, and the electrostatic precipitators are types with additional information. The wet separator obviously uses liquid to filter, and information about this liquid is only required for the wet separator. The automatic roll band filter is a filter where a band is used to filter something, and this band is continuously moving. And there you've got to have information about the position of this band, meaning if it's at the end of its way, or if there's still the possibility to roll on. And the third one is an electrostatic precipitator that uses electrostatic effects and high voltage units or electricity in general to filter small particles or droplets from the air, meaning those electrostatic precipitators also do use devices that are not necessarily used by a normal cartridge filter. Yeah, so in this overview, you've got, well, I may again show the way that we thought about those filter systems, meaning on the left hand, you've got the single filter system that I already talked about with all of its subsystems that are where the air connection of the filter system and the filter unit is identical, meaning that in the Companion spec, we make a differentiation or definition where we say either the filter system may be the device itself or the filter unit as part of the filter system may be the device. In this case, on the left-hand side, that's pretty clear. The filter system is identical, so with the filter unit, meaning that the device is the filter system. On the right-hand side, on the other hand, you've got this redundant system that I already showed beforehand, where the definition, what is a separate device or the separate filter unit and what is the filter system as a whole, is not as easy. And in this case, for example, the user of such a filter system may find identification or serial number plates on both of those filter units that form a filter system or a common or a connected filter system that is consistent of those two sub-filter units. And in this case, for example, the fans are shown here and are connected each one to in this user's relation to one of those filter units, so that the user of this filter system may easily identify how and or which filter, which fan is used to move air through what filter system, what filter unit. One of the main discussions that we had in the creation of our companion spec was the sensor monitoring type, because we are using a lot of different physical effects to filter particles and so on, and therefore there was no singular way to measure, for example, the filling rate of a single separator, meaning that we had to develop a way to provide a lot of flexibility to the user of our companion spec to make it fit the way his filter system is working. And this discussions led in the end, or in this discussion, it was very helpful that the machinery working group of the VDMA incorporated a way to generalize and demonstrate physical values as part of a device for all working groups. And I will, I think, show this in the next slide. However, we also used this to differentiate between three things, meaning that on the one hand, we just want to monitor those physical values. Then we've got physical values that are that we want to monitor, and the machine or the device may have a set point that it tries to use to change a physical value. And then there's the third thing where the user may change a set point to, in the end, change a physical value of the that is present while using the filter system or the filter units. And for this, we use this, first of all, the sensor monitoring type as a base type. And the main component or the main object for this is the process value type that I'll be showing in a minute. And we also added a way that this monitoring may be conducted in a digital or an analog way, meaning that either there may be a sensor that is showing values that are continuous, let's say from 0 to 10 volts, or from 500 to 5,000 pascals, or there may be a different way where the value is just controlled by a pressure sensor, for example, that'll change its state from 0 to 1 when a set amount of pressure or when a pressure limit is reached. And so those two ways are incorporated in this monitoring type definition. The process value type definition, on the other hand, gives us a wide range of values and variables that may be connected to one of those physical values. We've got the analog signal, meaning the value itself, and then there are additionally several values that may be added to this analog value that are describing it. You may have a deviation, you may have limits, and other status that are connected to it. And this is, for example, used in our filter units to say that the threshold of differential pressure that is used to describe the filter filling rate is reaching a set limit, and this limit may be used to replace the filter element inside of the device because it's full of dust or full of particles. And so I just want to make clear that this was one of the main discussions that we had while we were developing our companion spec, and this way of describing values helped us greatly. Other references that we're using in our companion spec are OPC 1000. I think this is quite well known, or PAEFS, the machinery for machine identifications, and the thing I just talked about, machinery process values for sensors, meaning that we tried at least to incorporate as many of those elements that were provided by other working groups, standardizing working groups, in our companion spec as possible, so that the users of our companion spec are as familiar with the concepts of it as is possible. The next steps of our companion specs are, first of all, to release a new candidate, 1.01, where we are integrating machine building blocks into our companion spec. And the main thing that we are looking into in the next month, and perhaps even years, is to prove the concept of our companion spec, to really bring it to life. And for this, we've decided in the air pollution department of the VDMA to create a working group that is focused on this implementation and will work together with the UMATI initiative. There will be an invitation to this working group, to this user group that is focused on implementation, and it will be open to, let's say, all interested parties that are using machinery, for example, that is connected to air extraction and filtration devices, or that are manufacturers of those devices or filtering systems.